processor. Secure data aggregation in wireless sensor networks, filtering out the attacker's impact. Let's discuss about this project. Secure data aggregation in wireless sensor networks, filtering out the attacker's impact. Abstract discuss about the abstract. Wireless sensor networks are increasingly used in many applications such as volcano and fire monitoring, urban sensing, and perimeter surveillances. In a large WSI, network data aggregation significantly reduces the amount of communication overhead and energy consumption. The research community proposed a loss desilent aggregation framework called synapses diffusion, which uses duplicate insensitive algorithm on top of the multipath routing schemes to accurately compute aggregates. However, this aggregation framework does not address the problem of false sub-aggregate values contributed by the compromised nodes. This attack may cause large error in the aggregate computer at the base station, which is the root node in the aggregation hierarchy. In this paper, they make synapses diffusion approach secure against the above attack launched by compromised nodes. In particularly, they present an algorithm to enable the base station to securely compute predicate count as sum even in the presence of such an attacks. Our attack resilenting computation algorithm compute the through aggregate by filtering out the contribution of compromised nodes in the aggregation hierarchy. Extensive analysis and simulation studies show that our algorithm outperforms compare our existing approaches. Data flow diagram. Let's discuss about the data flow diagram. Network formation. Here we set the simulation area range and the number of nodes, and then set each nodes sending and receiving range and simulation time set to form the network, and then implement the synapses diffusions aggregate framework. It is integrated with the duplicate sensitive algorithm. In the synapses diffusions, main challenges for supporting the duplicate sensitive aggregate correctly for all possible multiple path propagation schemes. So we first send the request to all its neighbor. If the check replay, if get the replay, construct the path. Otherwise we send the request. If the constructed path to check the traffic is high, use the attack resilient computation algorithm. In this algorithm activated by the base station, because base station to derive on incorrect aggregator by relaying a false aggregator to parent node, a compromised node maybe contribute a large of error to the aggregate. The attack of the false sub-aggregate attack, falsified sub-aggregate attack to the attacks re-silencing computation algorithm to filter the compromised node or otherwise malicious node, and then synapses diffusions robustically reconstruct the new route to data transferred, and then aggregator framework. Performance analysis is used to evaluate the performance of the proposed system. In the evaluation output is used to compare the existing system from the graph format to display the output. That graph is used to display the throughput, packet delivery ratio, and delay time. All are compared to existing and proposed system and then displayed. It is the performance analysis. Running procedure. Let's discuss about the running procedure. Open the terminal window and then change the directory. Use the cd command, cd, and space the particular directory name to change the particular directory, and run the tcl file. Use the ns command, ns space particular tcl name, and then run. This process takes a few minutes, and then run the NAM window. Open the NAM and select the numpad, play the command button and then run the procedure. If there is wireless node is moving and wired nodes are interconnected, here data aggregation process is performed in this base station. Base station monitor the aggregated data and route traffic. If used the synapses diffusion aggregate framework, and then if check the duplicate aggregator is occurred or not, and the compromise node are performed here. Yellow color node is compromise node is used the silent computation algorithm, and that algorithm perform the count on some mathematical methods to analyze the aggregated data and partial aggregated data to overcome or block the compromise node and to construct the and synapses diffusion used to construct the reroute. Close the NAM window and then execute the graph file. Use the GNU plat and specify name that plat. Here we use the star means execute on platform. GNU plat is used to run the plat file. In this graph we explain the end-to-end delay. In this graph show the end-to-end delay in existing system and proposed system comparison. The x-axis is the simulation time and y-axis is the end-to-end delay seconds. The red line is the existing system and here the green line is the proposed system. Compared with the existing and proposed system reduce the delay time in end-to-end node, and then reduce the packet delivery ratio. Y-axis is the packet delivery ratio and x-axis is the simulation time. Here we compare the existing and proposed system. Existing system is red line and proposed system is green line, and compared with the existing and proposed system, packet delivery ratio increased in the proposed system. And then run average packet loss. Average packet loss means in our project compared with the existing proposed system, packet loss in y-axis and simulation time is x-axis. Compared with the proposed and existing system, proposed system reduce the average packet loss. Use the synapses diffusion aggregated framework. Throughput. Simulation time versus and throughput increase there compared with the proposed and existing system. Proposed system increase the throughput. In our project, main objective is to block the compromise node to increase the throughput and packet delivery ratio. Here we use the synapses diffusion aggregated framework to framework is integrated with the duplicate sensitive algorithm to overcome duplicate synapse aggregated data, and resilient computation algorithm used to block the compromised nodes. Is this algorithm used count on some methods to increase our throughput and packet delivery ratio and reduce the delay time and packet losses. Thank you.